Everybody, welcome back to Tech Junior Tutorials. My name is Lee Warwick Jr. and we're doing Advent of Code. Today is day 13. Today's puzzle was amazing, blew my friggin' mind. If you see my brain lying around somewhere, please scoop it up for me. This one was an arcade game that's running in the terminal, so total madness. Let's check out the puzzle itself. So this is day 13 care package. They say, you're getting kind of bored in space. It's day 13, Friday the 13th. But this ended up being a pretty lightweight challenge. So again, running on int code. So some people, including myself, were like, "Ah, geez, here we go again." But today's puzzle is actually like a working arcade game. So they give you an input down here, and it is a massive amount of stuff. Just huge input. So that's all going to run on our existing int code program from day 9, which has all the features, has the relative base, the expanded array, all that good stuff. And so what they tell you is that the input software, or the int code software, is going to, it doesn't say anything about input, so it only says output. So it says it's going to output groups of 3 instructions. So it's going to give you an X, a Y, and then a tile ID. And so here's the different tiles you can get coming out of that third instruction. So basically, if you did your int code software correctly, you would just pass it some kind of function to call for output. And every time it outputs something, you receive sets of 3 values, and then it loops over again. So what they want you to do is pretty simple. It's just count the number of block tiles. So count the number of 2s that it outputs. So I was a little thrown off by that. I thought, man, that seems pretty dang straightforward. So yesterday's puzzle, day 12, totally ruined me. It was super difficult. I made it a little bit harder on myself because I thought through a possible answer, came home and tried it, but then had a typo and then ended up spending hours and hours on it. So check out that video if you want that whole story. But essentially, by the time I finished part 2 of day 12, it was after midnight, so day 13 had dropped. And so when I saw this and was like, man, this seems really simple. I bet I can do part 1 right away. I pretty much was able to. So looking at my code, I've just copied over the same int code chunk that I've had from day 9. So it's a couple of big functions that parse the giant array all the way through, and it runs on a, where are we at? Sorry, I keep scrolling through this whole giant thing. Runs through a while loop. So I just made like a pretty lazy decision right here, and instead of converting this to a dictionary or making like some dynamically expanding list or something like that, I just added 10,000 spots to whatever the input is right off the bat. And that's worked out so far, thankfully. But yeah, so all this does is it runs through that list until I get an index of -1, which comes off an opcode of 99. So the other things, like do other things to that list. Check out the other videos for all that. For today, though, we just have to worry about the input and output. So if you look at my int code program or function, it takes the program, which is that list of instructions we looked at, that huge list of numbers, and then an input method. So every time it needs an input, it's going to call that function. An output method. So every time it needs to output a value, it's going to call a function and pass that value in. And then the index that you're supposed to start at. So that defaults to 0 and output defaults to print. So what I needed to do for today was basically just count the outputs. So I could have just done like a mod the actual value. Well, yeah, I could have done like a Boolean or a state variable or something like that that said like, now I'm doing X values, now I'm doing Y values. But at the time I was doing this, I was super tired, so I just said, heck with it, I'm just going to count and use a counter and mod 3. And if it's 0, that means it's the first instruction, should be an X. If it's a 1, that should be the Y. And I'm sorry, I started at 1. So I started, the first thing is going to be X, and then 2 is Y, and then the count reaching 3 is going to be the final value. So it's like X position, Y position, actual value, and then it updates this dictionary with the actual value. So I get a dictionary, and then I just do the length of that at the end of this. And I went with a dictionary and not a list because I was worried about this thing printing over the same position more than once, and wondering like, ooh, what if they're going to get me with some kind of trick, and I won't be able to get the value right away. So I went ahead and kind of overcoded that bit a little bit. But yeah, once I do that, I also have a dummy function for inputs because I don't have a default one attached to my encode program. I just say like, hey, they didn't say anything about inputs, so if it does call for an input, go ahead and throw an error and stop the program and tell me like what happened, and I'll go reread the instructions again. But nope, it didn't actually need any of that. So if we run that, it runs right away, 239, and boom, that's the answer. So I was like, man, that was not bad. It only took me a couple minutes to code that up. And so then I was curious, like, okay, let me read part 2 and then I'll go to bed. Once I read part 2, I couldn't go to bed. Part 2 then says like, hey, you're actually going to play the game. And I said, there's no way that's possible. So what they tell you is that now you have to insert quarters into it. So memory address 0 is the number of quarters that you have to play. So you need to change that to 2 for it to actually run. And then it says the arcade cabinet has a joystick, and the joystick is going to give the intcode program inputs of 0, -1, or 1. So basically you have a function that's going to hand off a 0, -1, or 1 to intcode, and that's actually going to move the paddle. So then the last part of this is it says there's a segment display that says the actual score that you have. So anytime you get coordinates of -1, 0, that's the value that's coming is not an actual thing to print on the game board. It's going to be the actual score value as a number. So then it says you have to beat the game and break all the blocks. So it wants to know what's your score at the end of it, and actually, in order to actually solve the puzzle. So I thought for this, because they're actually giving me the program and telling me like you can play it and whatnot, I had to try it. So they don't tell you that you have to do any of this, but I went ahead anyway and decided that I'm gonna code a grid for this thing and actually like visualize it. So I basically scrapped almost all of what I had from the first part because I didn't really need it, but I do count all my coordinates. And I have like my current coordinate, I have a score variable, I still have the count for just purposes of figuring out what is an X, Y, or Z value. Then I create a grid that is the size of the maximum value of X and the maximum value of Y. So what I did was I ran this once and saw like, I printed total coordinates and looked at all the positions and saw there were no negative numbers. So I was like, okay, so this must be a 0, 0 base grid. 0, 0 is in the top left, max value should be in the bottom right. And so I did some more coding where I looped through again, and I said, like, give me the very biggest X value and the very biggest Y value. So the biggest Y, I think, was like 21, and I think the biggest X was 43, which is kind of weird, but hey, whatever. So I went ahead and made these a little bigger at first, but then I trimmed them down to the actual size of the board. And then I made a function to print the grid. So using the same tricks that I've learned from the previous puzzles, I made using the OS class, which I had to import at the top. I use this code that like clears your terminal after each print, or actually in this case before each print. And then it just prints each row in the grid and prints it as a string. So each line of the terminal will have one row of the grid joined together as a string joined on a space. And then after printing the entire grid, go ahead and print the current score. So after that, I used, let's see. So I've got the grid stored as a 2D array. And so now the only thing that I'm doing is I'm parsing the actual outputted value, and I say like for a 0, that should be a blank space, just make it a space. If it's a 1, that should be a wall, so I make walls X's. Actual blocks, I made hashtags, and then the paddle, I made an equals because I couldn't really think of anything else to use. And then for the ball, I used the at symbol because it was circular, but I could use like a 0 or something. I don't know. And then I added some other fun stuff, which we'll talk about. So for the actual inputs, what I first did was I'd scrap my previous input function. Now I said, okay, if I'm gonna ask for input, I'm gonna ask the user for input, so me. And at first I was just typing in -1 and 1. But then I said like, okay, let me just do Z and X since they're right next to each other on my keyboard. And every time that the game asks for input, I'll just give it 0x and that'll move the paddle left and right. And so, believe it or not, this actually runs. So I've got some other cheats to do. So we'll talk about that in a second. But let's take a look at this freaking game because it's amazing. So if you run this, it's actually going to print a game board. Believe it or not. So my terminal, I'm on Windows, and this is a Bash shell, so it's not quite as smooth as you might see on like a Mac or something. But yeah, this is actually running. So there's the ball, and there is the paddle. And now if I type Z, I can move left, and X moves right. And if I do nothing else, the paddle doesn't move. So I'm pressing enter to give the input. But you can actually play this game. I just lost. So it's not an easy game to play, which I realized pretty quickly. Especially like in a terminal. Maybe if I was doing this in Node, I could find some other tricks, or using like Pygame or something to keep like a stream of inputs from the user and like queue up what the user is currently holding, if they're holding left or right or something like that. But it like basically what amounted to 12:30 in the morning. I just wanted to kind of get going with this. So keep losing this. It's not an easy game to play. I did a little bit better, surprisingly, in the middle of the night than I'm doing right now on this video. But that led me to think. I started playing it for a while. So after I was playing it for a while, I got my score up to like 1,000 or something. But if you actually look at this board, there's like a ton of blocks on here. So if you're going to sit down and play this thing for real, it would take kind of a long time to win, right? So you can see, like, I don't think the score is going up a certain amount per each block that it hits. It looks like it's kind of, at least I can't tell just by looking at it, random or exponential or something like that. It might be a random number. Now it can't be, because the puzzle answer is what's your total score at the end when you win. So I didn't really think about that because I figured there was an easier way to win. And in fact there is. Oh, let's go to the right. So you can see how long this is taking and like how many blocks there actually are. So you can see this is like amazing. There's like collision detection and stuff running. The @ symbol is looking for hashtags around it, which are actually all coded as numbers within that int code array. And then when it passes the boundary, you lose the game, which is like bananas. So anyway, I thought there's got to be a way to beat this, like, you know, cheat basically. So I came in here and I made a cheats enabled variable. And if you come down here and look in my input function, what I'm doing is I'm tracking the ball position in here. If I get a tile that's the paddle, or supposed to be the paddle, or tile that's supposed to be the ball, I go ahead and grab those coordinates, and I really only need the x coordinate, but so I grab those coordinates and I say like, hey, if the ball is further along than the paddle, go ahead and move right. So if the ball is further right than the paddle, move right, move the paddle right, and the opposite for the other direction. So if the ball is less than the paddle's position, move left. Otherwise, hover. Don't give an input, just stay where you're at. So if we run that, and again, this takes just a second to print, but it's pretty cool. I haven't gotten tired of watching it yet, believe it or not. Even though like I didn't code this encode program, I only coded like the parts that are running that program. This is like amazing. So I haven't gotten tired of it, but you'll see in a second here, like now I can get the program to play itself. So I've got cheats enabled, or God mode, or whatever you want to call it, from back in the day. So yeah, now this is just going to play itself out basically until that ball kills all of the blocks or destroys all the blocks, which is really neat. It's hard to overstate how exciting and like nerdy and awesome this is to see this pop up after doing like a super hard puzzle like day 12. This is just amazing. So I always dream of making games like this, using like ASCII art and making some kind of like terminal game. Reminds me of that movie with Matthew Broderick, War Games, I think it was. So this is just like really, really neat. But you may notice like we've been letting this run while I've been kind of gushing about this puzzle, and it's just taking forever. So I thought like, man, I think really like my print grid function is slowing this down because it's limited by how fast I can print to the terminal. It's blocking, right? So we can go ahead and stop the game. And now another optimization I made was, well, why don't we not print the grid at all? We could just print the score at the end. So I've got a display enabled flag that I just put above print grid in the actual output loop. So now if I don't have the display enabled, it'll just run until the end and like auto beat the game. So if we turn display enabled to false and then run this again, we'll see how fast it is. So it's running, it's printing, it's thinking, bam, there's our score, 12099. So we look over at Advent of Code, there it is. So I really thought this was awesome. Again, it's hard to overstate how cool this is. I don't want to scream into the microphone or anything, but this just tickles me to no end. So I really had a blast doing this one. Looking forward to tomorrow. It's nice to get a challenge that's neat like this, and then I feel like I learned something at the end of the day, or at least I got to practice some of the skills that I've learned from the previous days. But at the same time, like beating it after midnight, I kind of missed having something to look forward to after work today. So that part's kind of sad, but otherwise, like, man, this is really it's hard not to recommend Advent of Code to people after seeing this. I know I've kind of bashed some stuff before and said like, man, if you're a beginner programmer, like maybe stay away from this. And I think that's still the case. Some of these problems are super tough, and I wouldn't really recommend this to somebody that's just starting out programming. But if you've been programming for a while, if you're a front-end developer or whatever, like, man, what a great way to practice other skills and get your mind wrapped around like data structures and algorithms. And then also like, hey, as a front-end person, like I am, being able to print a grid in the terminal is like, that's awesome. So really had a blast with that one. Yeah, man, just what it blows my mind every time I think about it. I took like GIF screenshots of it and put it on Twitter, just like I saw people do for the laser puzzle from a couple days ago. So yeah, definitely check these out. I may even check out past years after doing this year's, just to see what all is going on and if I can learn some more stuff. But this is amazing. Like the best programming education and entertainment you can get for free. So definitely check it out. Adventofcode.com, and follow the the creator on Twitter. I forget his name off the top of my head. It is... Stand by. Eric Wassel. It looks like Wassel. Wassel. So this fellow, Eric Wassel. Follow this guy on Twitter. Tell him like, good job, thank you. Keep doing what you're doing because this is amazing. Major kudos to Eric for making this. I couldn't even imagine building an Encode program that does all of that stuff. That is crazy. So, all right, that's all I've got for day 13. Turned out to be a not unlucky day, but actually a lucky day. So that was good. And join us. Actually, tomorrow is going to be Saturday and Sunday. So 14 and 15 may come early next week as opposed to Saturday and Sunday. Depends on how much time I have. But yeah, join me for the next videos. Keep playing along at home. Let me know how you're doing in the comments. And yeah, enjoy. All right, I'll talk to you later.